In this example, we have the following relation given by the equation y is equal to x squared minus 9. And in part A, we want to find x and y intercepts. And then in part B, we're going to want to get an idea of what the graph of this relation would look like. Eventually, we'll get to part C, talking about symmetry, but for now, we'll just focus on parts A and B. So in A, if we want to find x-intercepts, that means we set y equal to 0 and solve for x. Okay, this is what we do in general. So in this case, we would set y equal to 0. Now we have the equation 0 is equal to x squared minus 9. And so to solve this, for example, we can add 9 to both sides, and that would give us x squared is equal to 9. And so now we need to be careful. We need to think about what values, when we square them, give us 9. And so one of them is 3, since 3 times 3 is equal to 9, but in many cases, equations can have more than one solution. And there's another, namely x is equal to minus 3, since minus 3 times minus 3 gives me positive 9. So we have two solutions to this equation, and generally what you can do is I want to undo the square operation, so I do that by taking the square root of both sides, and I account for this fact that there may be more than one solution by putting a plus or minus. So in this case, I would get plus or minus 3, and so we don't want to forget the fact that we might have more than one solution. To find the y-intercepts, we are going to set x equal to 0 and evaluate to find y. So in this case, I have y is equal to, in place of x, goes 0, minus 9, so we get that y is equal to minus 9. And I should say that these intercepts are points. So I'd want to give this as coordinates: x is equal to 0, y is equal to minus 9, and for the x-intercepts, I should give those as coordinates as well. So that would be 3, 0, and minus 3, 0 are the two corresponding x-intercepts. And down here, we have the y-intercept. Okay, and so now in part B, let's go ahead and try and plot this graph of this relation. And so in order to set up a graph, let's first set up a table of some points that are going to be on that graph. And so I'm going to organize this to two columns, where the first column are some x values that I'll select, maybe minus 3, minus 2, minus 1, 0, 1, 2, and 3. And then I'm going to have a second column where I calculate the corresponding values. So the way I find the y value is using the equation y is equal to x squared minus 9. So at 3, when x is minus 3, I plug in minus 3, minus 9, and that gives me a y value of 0. Since minus 3 squared is 9, 9 minus 9 is 0. When x is minus 2, I get minus 2 squared, which is 4 minus 9. That gives me a y value of minus 5. When x is minus 1, I get 1 minus 9, which is minus 8. When x is 0, I get minus 9. When x is 1, I get minus 8. And when x is 2, I get 4 minus 9, which is minus 5. And finally, when x is 3, I get 0. So a couple of observations, and that is, remember we found these x-intercepts over here, and that matches what we found on the table. So we found that when x is 0, when x is minus 3, y is 0. When x is 3, y is 0. And we also verified our y-intercept by saying when x is 0, y is minus 9, and that matches on our table. Okay, so now we have an idea of some points that we can plot. At least we found 7 such points. So plotting them over here, I have the point when x is minus 3, y is 0. Plot that over here. The next one is when x is minus 2, y was equal to minus 5. When x was equal to minus 1, that was the next point that we had, y was equal to minus 8. When x was equal to 0, y was equal to minus 9. When x was equal to 1, y was equal to minus 8. When x was equal to 2, y was equal to minus 5. When x was equal to 3, y was equal to 0. And now we can graph these points by drawing a curve that connects those points, and we can extrapolate this to other values of x where we didn't necessarily plot this relation, and we get the graph of this relation that I've drawn in blue. And so this graph in blue, a couple of things to point out, in that these intercepts that we found in part A, these x-intercepts, these graphically are places where the curve crosses over the x-axis at minus 3, 0, and 3, 0. This y-intercept at 0, minus 9, this corresponds to where the graph crosses the y-axis at 0, minus 9. And we started with this relation which was given as an equation. We could represent it as a table that we did over here, and then we can graph this relation as we did in blue. So we've represented this as an equation, as a table, and as a graph.